The automotive landscape is undergoing a monumental shift, propelled by the rise of electric vehicles. What began as a niche interest for environmental enthusiasts has rapidly transformed into a mainstream phenomenon, challenging over a century of internal combustion engine dominance. But beyond the hype, what are the tangible advantages and genuine drawbacks of EVs in today's world? And crucially, as technology accelerates and global priorities evolve, what does the road ahead look like for electric cars over the next 2 decades? We'll deep dive into the present reality and future trajectory of this disruptive technology, dissecting its economic, environmental, and practical implications. One of the most compelling arguments for electric vehicles lies in their operational cost efficiency, particularly concerning fuel. While the upfront purchase price can be higher, EV owners consistently report significant savings at the pump, or rather, at the charger. Analysis shows that the cost to charge an electric vehicle is typically 70 to 80% cheaper than refueling a comparable gasoline-powered car. This dramatic reduction in daily running costs translates into substantial long-term financial benefits, making EV ownership increasingly attractive for budget-conscious consumers seeking to minimize their transportation expenses. Beyond fuel, electric vehicles inherently offer a simplified maintenance experience. Traditional gasoline cars are complex machines with hundreds of moving parts, requiring regular oil changes, spark plug replacements, and intricate engine tune-ups. EVs, by contrast, possess far fewer mechanical components. There's no internal combustion engine, no transmission with multiple gears, and no exhaust system. This drastically reduces the number of wear-and-tear items and scheduled service visits, leading to significantly lower maintenance costs over the vehicle's lifespan. It's a testament to engineering simplicity translating into tangible owner benefits. Perhaps the most widely recognized advantage of electric vehicles is their positive environmental impact. EVs produce zero tailpipe emissions, meaning no harmful pollutants like nitrogen oxides or particulate matter are released directly into the atmosphere during operation. This contributes significantly to improved urban air quality, reducing smog and respiratory illnesses. Furthermore, when powered by renewable energy sources, the overall carbon footprint of an EV is substantially lower than that of a gasoline car, playing a crucial role in mitigating climate change and moving towards a more sustainable transportation ecosystem. The driving experience in an electric vehicle is markedly different and, for many, superior to that of a conventional car. EVs deliver instant torque, providing immediate acceleration from a standstill, which can be particularly exhilarating. There's no lag as an engine spools up, power is available precisely when you need it. Coupled with this performance is a remarkably quiet and smooth ride. The absence of engine noise and vibrations creates a serene cabin environment, enhancing comfort and reducing driver fatigue. This blend of responsive power and refined quietness redefines the driving pleasure for many owners. Governments worldwide have actively promoted EV adoption through various incentives, though these are gradually diminishing as the market matures. Historically, these included tax credits, subsidies, and preferential treatment like HOV lane access. Beyond individual financial benefits, EVs also offer a macro-level advantage: energy independence. By shifting away from fossil fuels, nations can reduce their reliance on volatile global oil markets and enhance national energy security, especially when EVs are powered by domestically sourced renewable electricity. This strategic benefit positions electric transport as a cornerstone of future energy policy. Despite their long-term savings, one of the most significant hurdles to widespread EV adoption remains the higher upfront purchase price. Electric vehicles, especially new models with advanced battery technology, often carry a premium compared to their gasoline-powered counterparts. This cost difference can be substantial, placing EVs out of reach for a segment of the market, particularly those on tighter budgets. While battery costs are declining and more affordable models are entering the market, this initial investment still represents a considerable barrier for many potential buyers, impacting market penetration. Range anxiety, the fear of an EV running out of power before reaching a charging point, is a persistent concern for many prospective buyers. While average EV ranges are improving, they still generally fall short of the distances a gasoline car can cover on a single tank. This psychological barrier is particularly relevant for long-distance travel or in regions with sparse charging infrastructure. The perceived limitation of range influences purchasing decisions and travel habits, as drivers worry about finding chargers, especially during unplanned diversions or in emergencies, making planning essential. Another practical disadvantage of EVs is the time required for charging. Refueling a gasoline car takes mere minutes, a quick stop that fits seamlessly into a busy schedule. Charging an electric vehicle, even with fast chargers, can take significantly longer, often 30 minutes to an hour for an 80% charge, and much longer for a full charge at home. This extended waiting period can be inconvenient, especially for drivers accustomed to rapid refueling or those with limited access to home charging solutions. It represents a fundamental shift in user behavior and expectations. Electric vehicle batteries, while advanced, come with their own set of concerns. Firstly, battery degradation is a reality. Capacity can diminish over time in use, potentially impacting range and performance after several years. Secondly, the sourcing of raw materials like lithium and cobalt raises ethical and environmental questions, often associated with mining practices in certain regions. These concerns relate to labor conditions, ecological damage, and geopolitical dependencies. Addressing these issues through responsible sourcing, technological innovation, and robust recycling programs is crucial for the sustainable growth of the EV industry. While charging infrastructure is expanding, significant gaps remain, particularly in rural areas or apartment complexes where home charging is impractical. This uneven distribution exacerbates range anxiety and limits accessibility. Furthermore, the mass adoption of electric vehicles poses a potential strain on existing electrical grids. If millions of EVs simultaneously plug in during peak demand hours, it could overload local grids and lead to power outages. Strategic grid upgrades, smart charging solutions, and effective load management are essential to accommodate this transition without compromising energy reliability. Looking ahead, the future of electric vehicles hinges significantly on advancements in battery technology. The most promising development is solid-state batteries, which promise a revolutionary leap. Unlike current lithium-ion batteries that use liquid electrolytes, solid-state batteries utilize solid electrodes and electrolytes. This innovation is expected to deliver higher energy density, meaning more range from a smaller, lighter battery pack. They also offer faster charging capabilities and significantly enhanced safety by eliminating flammable liquid components. This technology could fundamentally transform EV performance and market appeal in the coming years. The cost barrier for EVs is set to diminish dramatically. Projections indicate a 50 to 60% decrease in battery costs within the next decade, making electric vehicles far more affordable and competitive with their gasoline counterparts. This cost parity will be a pivotal moment for mass adoption. Concurrently, charging speeds will see exponential improvement. By 2030, advancements in fast charging technology are expected to enable an 80% charge in just 10 to 15 minutes, largely eliminating the current inconvenience of long charging times and making spontaneous long trips much more feasible. Range anxiety, currently a significant drawback, is poised to become a relic of the past. As battery technology advances and energy density improves, the average range of electric vehicles will continue its upward trajectory. By 2035, the typical EV range is expected to comfortably exceed 600 kilometers on a single charge. This extended range will effectively eliminate the need for frequent charging stops on most journeys, providing comparable or even superior travel convenience to gasoline cars and unlocking greater freedom for long-distance drivers, fundamentally changing perceptions of EV capability. The shift towards electric vehicles is not merely a trend, it's an inexorable march towards market dominance. In 2023, EVs constituted about 15% of new car sales globally. This figure is set to skyrocket. Projections indicate that by 2030, electric vehicles will capture 30 to 40% of all new car sales. Looking further ahead to 2040, EVs are expected to command over 70% of the global new car market. This exponential growth underscores a fundamental transformation of the automotive industry, positioning electric vehicles as the primary mode of personal transportation worldwide within the next 2 decades. The future of EVs extends beyond mere transportation, integrating them into a broader smart ecosystem. Vehicle-to-grid, or V2G technology, will allow EVs to not only draw power from the grid but also feed electricity back during peak demand or emergencies, transforming them into mobile energy storage units. Concurrently, the integration of autonomous driving capabilities with EV platforms will create seamless, self-driving electric vehicles. This synergy will offer enhanced convenience, improved safety, and optimized energy management, fundamentally reshaping urban mobility and personal transportation experiences in the coming decades. The regulatory landscape will continue to accelerate EV adoption. Stricter emission standards, coupled with outright bans on the sale of new internal combustion engine vehicles in many regions, will push consumers towards electric alternatives. Simultaneously, the industry is moving towards a circular economy for batteries. This involves robust recycling programs to reclaim valuable raw materials and the development of second life applications for used EV batteries, such as stationary energy storage. These initiatives will address environmental and ethical concerns, ensuring the long-term sustainability and resource efficiency of the electric vehicle revolution. From significant present-day advantages like reduced running costs and environmental benefits, to emerging challenges such as upfront price and infrastructure gaps, the electric vehicle story is one of dynamic evolution. Looking 2 decades ahead, the trajectory is clear: a future dominated by EVs boasting superior range, rapid charging, and integrated smart technologies. While obstacles remain, the combined forces of technological innovation, decreasing costs, and supportive regulatory frameworks are undeniably steering us towards an electric future. The automotive industry is not just adapting, it is being fundamentally redefined, promising a cleaner, quieter, and more efficient era of mobility for all.